So, hi, I'm going to start by showing the results from my green economy model. First, I'll start with the process that I've built here. So, first, we start with reading the CSV file. The dataset that I've imported here is going to be my world sustainability dataset. So, I'll just quickly show how the dataset looks. So as you can see, this is the data set. It has country name, the year, and these are the few elements that shows the relation, that is the electricity, then the national income, then there is the excluding particulate emissions for green economy. These matters saving carbon dioxide damage. So all these are the parameters which are present, saving natural resources. And there are some missing values and outliers in the data set, as you can see. We also have null values. So like this, we have multiple columns over here in the data set. So now I just want to show you the model over here. So first we read the CSV, we replace the values which are probably missing, and we replace it with forward or backward filling. Then we do normalization, which basically we use a Z transformation to make sure that the model performs better. Then is the correlation matrix, where we check like the access to electricity and the relationship between the two columns basically. Finally, we split it into training and testing with 1:4 ratio. And then we have the random forest over here. It's a model which are used to train our training data set over here. Finally, we'll use a performance evaluation. Here we'll basically use RMSE, which is the root mean square error, which is regression, and we also have other classification report parameters like accuracy, precision. Finally, we'll visualize the results using the dashboard of ALTAIR AI Studio to visualize the final model's results. So I would like to show what I've got here. I have used these few models: the generalized linear model, deep learning model, decision tree, random forest, and now I'm going to show the results. So we could start with the statistics over here. Related to the model, you get a visualization. You get the relative error, as you can see. If you want to further open the visualizations, this is how it looks. All of them have a count of 1, and now if I go to gains, gains are not significant here, as you can see. The error, however, shows a different matrix here. So as you can see that the relative error is 3, 1, 1, and 1 again for the final data set. If I just plot this, maybe using a different type of a plot, maybe a spline plot, you can see that this is the relative error, which is about 2. Apart from this, if I just go to the auto model over here, this is how it looks, and I I did this based on my data set. So as you can see over here, when I go to the results, we have made one folder for each of the things here. So here, this will take me to the correlation matrix. So this is the correlation matrix. Next, I have the decision tree model. Under the decision tree model, if I just go to the production model here, it's going to show me a graph. So as this is the decision tree model, you can see this is how the graph looks like. It shows the graph with node labels and edge labels over here. Similarly, I could click on support vector machine and then again go to the production model here. So it's going to load the production model. So it gives me a kernel-wise analysis over here with support vectors, these many bias of 1.653. Now if I go to the data and I just go see my transform data, this is how it looks. If I just go to auto model, it's going to take me to this place, and so if you see, I get a statistics for my different column values over here. Accent to carbon dioxide, electricity, national income, excluding particulate matter. If I just open these, then I could get a histogram value of emission of the particulate matter over here. Um, well, this is how it is for now, and thank you so much. I also wanted to show a couple of graphs that I had generated, and I'll just open the PPT here. So as you can see, these are the graphs that I had initially generated. I had predicted on the carbon emission, and I had gotten this continent wise. Then I chose outliers, and I made distance based outlier detection as my parameter, and local outlier factors I had set both to true. And you can see this is what I had got as the result. All these are true and outliers are detected over here. And you will also get the outliers for each of the columns that I have used. So you get a minimum, maximum, average, you get a correlation matrix. Similarly, I've used to train my data set in different models. And we have found out the most important factors of prediction using the deep learning model over here. We also use decision tree predictions, gradient boosted trees, support vector machines. As you can see, this is the bias value. I have done my certification over here. Is as a machine learning certification. I took the test and I have got 15 out of 20. This is my certification. And finally, this is a graph that I had gotten to plot using a parallel coordinates graph across all continents for 4 different parameters. As you can see, one is a net forest depletion, then we have the consumption and expenditure of GDP, and emission damage. These are all essential for a green economy. So that's the final. And I think that's all I have to show. This was one graph I had got from the decision tree model. As you can see, it's giving me, so this is coming from the SVM model. As you can see, this is the true values coming versus prediction, and it's lying across the red line. The outliers aren't very high. So this is a good model at the SVM. So yeah, thank you so much.